Today I will discuss on cache memory. Cache memory is small and fast memory used to increase the instruction processing rate. Its operation is based on the property called locality of reference inherent in programs. Analysis of a large number of typical programs shows that the CPU references to main memory during some period tend to be confined within a few localized areas in memory. In other words, few instructions in the localized area in memory are executed repeatedly for some time duration and other instructions are accessed infrequently. This phenomenon is known as the property of locality of reference. This property may be understood considering that when a program loop is executed, the CPU repeatedly refers to the set of instructions in memory that constitutes the loop. Thus, the loop trains to localize the references to memory for fetching the instructions. Cache memory is a small and fast memory that lies between the main memory and the processor. It bridges the speed gap between the processor and main memory. Frequently accessed segments are stored in cache to reduce the memory access time. So cache memory is very fast. Why? Because faster electronics used, cache memory has fewer locations than the main memory, which reduces the access time. The cache is placed closer to the CPU than the main memory. These are the various reasons why the cache memory is being fast. So, effectiveness of the cache is based on the property of the computer that is called locality of reference. Most of the program's time is spent in loops or procedures called repeatedly. The remainder of the program is accessed infrequently. So, the cache memory works on this property. There are two types of locality. One is temporal locality, that is locality of time, and another is spatial of locality, that is spatial locality, that is actually locality in space. Suppose an item is referenced. It will likely be referenced again soon. This is called locality of time. That is, the data is reused. Okay. So, this is caused by the spatial program construct such as iterative loops or subroutine. If an item is referenced, that items in neighboring address will be likely to referencing soon. That is called locality of, that is called actually the spatial locality. Operations on table or arrays involve access of a certain clustered areas in the address space. The processors does all memory operations with cache. When the CPU refers to memory and finds the word in cache, it is said to be produce a hit. If the word is not found in cache, it is in main memory, it counts as miss. Minimum amount of data transferred between the cache memory and main memory is the block. The ratio of the number of hits divided by the total CPU references to the memory, that is hit plus miss, is called the hit ratio. So what is the use of a cache memory? When a read request is received from the CPU, the contents of a block of memory words containing the location specified are transferred into the cache one word at a time. When the program references any of the locations in the block, the desired contents are read directly from the cache. The correspondence between the main memory blocks and those in the cache, that is specified by the mapping function. We will discuss in different lectures about the different mapping function of the cache memory. When the cache memory is full and memory word that is not in the cache is referenced, the cache control hardware must decide which block should be removed to create space for the new decision by replacement algorithm. In another lecture, we will discuss about the replacement algorithm. So, we understand today that what is the different type of locality of reference, that is the temporal locality and spatial locality. Now, we will discuss about the writing to the memory. Cache and memory become inconsistent when data is written into cache but not to memory. That is called cache coherence problem. And the strategies to handle the inconsistent data are there are two policies. One is the write through policy and another is write back policy. What is the write through policy? This is the simplest and most commonly used procedure to update the cache. In this technique, when the cache memory is updated, at the same time the main memory is also updated. Thus, the main memory always contains the same data as the cache. But it is a slow process, since each time main memory needs to be accessed. And another policy is write back policy. In this method, during a write operations, only the cache location is updated. When the update occurs, the location is marked by a flag called modified or dirty bit. When the word is replaced from cache, it is written into main memory if its flag bit is set. The philosophy of this method is based on the fact that during a write operation, the word residing in cache may be accessed several times, that is called temporal locality of reference. This method reduces the number of references to main memory. However, this method may encounter the problem of inconsistency due to two different copies of the same data, one in cache and another is main memory. So what are the advantage of the write through policies? That is the in this policy, update of cache and main memory simultaneously on every write. And the main memory is up to date with the cache memory at any time. This is its advantage. But all writes require the main memory access. Thus, it will slow down the system. If there is another read request for main memory due to miss in cache, the read request has to wait until the earlier write was serviced. And in case of the cache write back policy, data that is modified is written back to main memory when the cache block is going to be removed from the cache. Advantage is the system is the faster than the write through policy. Only one memory write while the cache block is removed, thus reduces the bus traffic. Writes to multiple words within the block require only one write to the main memory. It needs an extra bit, that is the disadvantage, to indicate which block has to be modified. 0 for not dirty and 1 for dirty, that adds the size of the cache. The techniques to improve the cache memory's performance is actually the average memory access time is the hit time plus miss rate plus miss penalty. So if the miss time is reduced, then the cache performance will improve. Again, if the miss penalty is reduced or hit time is reduced, then the cache performance will be increased. So if H is the hit rate, M is the miss penalty, that is the time to access the information in the main memory, and C is the time to access the information in the cache, the average access time will be, T average will be HC plus 1 minus HM. Hit rate is the number of hits stated as a fractional of all attempted access is called the hit rate. Then miss rate, the number of misses stated as a fraction of all attempted access is called miss rate. So if there are multiple number of cache, suppose C1 is the time to access the information from the primary cache and C2 is the time to access the information in the secondary cache, then the T average will be calculated with the help of this equation, where H1 is the hit rate in the primary cache and H2 is the hit rate of the secondary cache. Now we will discuss about the different cache misses category. So the compulsory misses means the very first access to a block cannot be in the cache. So the block must be brought into the cache. This is called cold start misses. Capacity means if the cache cannot contain all the blocks needed during execution of a program, capacity misses will occur because of blocks being discarded and later retrieved. And conflict, if the block placement strategy is set associative or direct mapped, conflict misses will occur because a block can be discarded and later retrieved if too many blocks map to its set. So the techniques to reduce the cache miss is the large block size, that will reduce the compulsory misses. Then the reduce cache miss rate, 8-way set associative cache, then 4-way or 2-way. It will increase the cost of the memory. And what is the use of the different victim cache? To reduce the conflict misses without impairing clock rate, one small fully associative cache called victim cache is placed between a cache and its refill path. This victim cache contains only blocks that are discarded recently from a cache because of a miss and that checked on a miss to see if they have the desired data before going to the next lower level memory. If it is found there, the victim block and the cache block are swapped. So, today we have learned about the cache memory, the locality of reference, the write back policy, write through policy, The different type of cache misses category, victim cache, and in next class we will discuss about the cache mapping. Okay.